Hey, this is OXDF, and today we're looking at the 2015 Advent of Code, Day 15, Science for Hungry People. Basically, I'm going to get a list of ingredients, and every ingredient has a capacity, a durability, a flavor, a texture, and a calories, some sort of measurement for each of them, right? And I need to be able to, so for each tablespoon of ingredient, that'll be like what this defines, right? So you have some plus or minus numerical measure of that, each one. So then I have to use exactly 100 tablespoons. And so I'm going to go through and figure out what is the best combination like of these two ingredients based on some scoring metric I'm going to get below. And so in this case, you know, they say if you have 44 tablespoons of butterscotch and 56 tablespoons of cinnamon, that adds up to 100, and it also produces the highest possible score. And so the way you get the score is you sum together the number of tablespoons times the measure for each ingredient, and then you multiply them all together. And if you have any negative numbers, those become 0. And you ignore calories for now. So I think that was a little bit confusing, but I guess we'll figure it out as we get going. I did solve this challenge years ago, which is why you have an answer here. But we do have the puzzle input up here. We have 4 ingredients instead of 2, which if you think about it, that actually adds, you know, over 100 different tablespoons, a ton of variety. So that's actually a lot. Yeah, let's go ahead and jump over to VS Code. I'm going to do my agenda script here for day 15. I went over this in detail in day 0 video, but basically it pulls the input.txt for me, and it makes a nice little template main for me to start working with. Strategy-wise, we're going to make I'm going to call it a properties struct. When I first started playing with this, I actually made it an ingredient struct, and then I got confused because I needed to use it later when I was combining ingredients. And so really I'm just going to keep it as properties and then let the variable name define what it is. The same way an integer can be lots of different variables. We're also going to make a pantry struct. It'll just allow us to keep our list of ingredients available. We'll do that as a hash map. And then also we'll have some functions for solving in there. So with that, let's go ahead and dive in. We'll start with the struct properties. And that will have capacity. Now we can see if I can spell I64. Now these are definitely I, not you, because we have signs. We had negatives. Durability I64. Flavor I64. Texture I64. And calories I64. So now we've got our property struct, and we're going to go ahead and see if I can remember how to do this. Derive. If I don't start typing it out, I'll never learn. Debug, like that. And so now we can derive from debug, so we can debug print some properties. We'll also come down here and make a struct. In fact, we'll derive debug that as well. They'll be yelling at me momentarily if it's not right. And we're going to make this pantry, and this is going to be our list of ingredients. So we'll call it ingredients, and that'll be a hash map with string, comma, properties. So it's going to take a string, like a name, and it's going to return a set of properties, and that's all we need for that. I get the feeling my extension is not working. Let me fix that real quick. Awesome. Okay, that's working. So now with hash map, we're definitely gonna have to use that. So we're gonna do use std collections hash map. That. Okay, now we got a hash map. Okay, now we're just complaining that we're not using any of that. So that's cool. So the first thing I want to do is read all my input into my pantry. So we'll do I'm really into doing this from. So we can do impl from string. So for pantry. And so now we can do function from, and it's going to take in s as a, let's make sure we get the right character there as a string. It's going to return a pantry. And now let's see, so first we're going to do, let's say let mut pantry equals, and so what are we going to do? Let's go ahead and create our pantry. So we'll do pantry, and then this will just be ingredients. And that is going to be hash map new. So we start off with a fresh, empty hash map. And we do that. Now we're complaining a little bit because we still need to return a pantry. So let's come here. Oops, not there. Let's go here and do pantry. So now we are returning a pantry. That's good. It doesn't like that we didn't mutt this yet, but we will mutt it in a second. So now we can do for line in s dot lines. So for each line, what are we going to do? We'll do let. I'm doing this. We've done this several videos recently. Tokens vec of strings equals line dot split on space dot collect, like that. Is that gonna work? Looks happy. What do we have? Ooh, let's fix this. You know, a lot of times the IDE helps you, but sometimes it just messes things up. Okay, so we're gonna split on collect. Now we can do pantry dot ingredients dot insert. And so what are we going to insert here? So first let's actually do let name equals toke. What is the name? Very first thing. So we can do toke 0. Now we have this semicolon or colon we have to get rid of here. So let's do toke colon. So we can do trim end matches like that. Now we got rid of any semicolons on the end, and then we'll do toString. So now we have name there. We've got our name as a string. So let's insert name, and then our value is going to be a properties object. And let's see if we can make this look a little prettier. There's capacity. And so the capacity is going to be toke of, let's see, 0, 1, 2. And it's going to be an int. 2.parse.unwrap. Durability. I think this is this all just going to be 2, 4, 6, 8, and 10. And we have to remember to strip off the commas. So let's come back here. We will do trim and matches, comma, dot parse. Okay, so that's going to look the same, right? We're going to grab this right here because this is what we want for all of these. So we'll do durability will look like that. Flavor, make all these on their own line first. Like that, like that, like that, comma, and now we got that there. What are we unhappy about here? We need to make pantry mutable. No, we already did that. Pantry.insert. We want to change all these. I don't think that's why it's yelling, but let's fix that. What we know. 8, 10. All right, what are we unhappy about here? Oh, we need a semicolon here. Beautiful, that was it. Okay, so now we're going to loop over each line. For each line, we're going to break it into tokens. We're going to get a name, and then we're going to insert a properties object with the name. So we're going to have this ingredients list that I can fetch by name, and I'll return all the properties for it. And then we just return pantry. And if we did this right, we should be able to say let pantry equals pantry equals data.into, like that. And we should even be able to do pantry if we can spell it like this. What are you unhappy about here? It doesn't. Oh, we don't. Oh, we need to debug print that. And now we run that. We get back our pantry with our ingredients, with our each. So chocolate has these properties, etc. Did chocolate have 005 -18? 005 -18. Sweet, it does. So we've read everything into our pantry. That's awesome. Now we need a way to score possible recipes. And so each recipe is going to be up to 100, or exactly 100 tablespoons, right? So let's come here and we'll do impl pantry, like that. And now we're going to have a function here called best score, and it will take self, and it will return an I64. And we're just dealing everything in i's, in signed integers here. So what are we going to do? We're going to say, so we can say, let's say let x equals And let's take a look. The strategy here is going to be self.ingredients. We're going to get the ingredients dot keys. And now it's going to give us a list of all the keys, the ingredients here. And we're going to pass that into this thing called combinations with replacement. I'm going to start it off with just like 4 right now, but we're going to obviously make that bigger. And so if we do that, now that is from iter tools, so we're gonna have to import that. Use iter tools, iter tools. And we're gonna have to add that to our cargo.toml file. Iter tools equals star, again, being lazy and not giving a definition here. And so what this thing right here is gonna do is it's going to return, basically it's from the list of ingredients. So it's going to return 4 of them, and it can be repeated. So in fact, we'll just do it this way. Let's just say 4, what do we call this? Combination, com in, then we'll print line. I think we'll need a debug print, and we'll do com. Let's see if this will work. What do we have? What are we unhappy about here? It needs to return a number, and then we return 0 for now. So what if we come down here, instead of printing pantry, we print pantry dot best score. That's not gonna, it's actually just gonna return 0, but like along the way, it's gonna print a lot. So let's see what happens. We're gonna download that. So you can see here, even just doing 4, it starts off with 4 chocolates. Then it starts off with 4 chocolates and a sprinkle, 4 chocolates and a candy, 4 chocolates and a butterscotch, 4 chocolates and 2 sprinkles. And so you can see it's actually cycling through. If you think of each of these as a recipe with 4, with exactly 4 tablespoons, now I can get all my combinations here. And there's a lot of them. Now, interestingly, order doesn't matter. That makes sense. So you can see that they get less over time, and that's because the order doesn't matter, just the total number. So this is perfect. This is exactly what we want, except I don't really want it to say chocolate, 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 chocolate. I want it to say 4 chocolate. And so what we're going to do is we're going to change this. Where do we go? Okay. In here, we're going to say, instead of saying combinations, we're going to make that an iterator. And then we're going to dedupe with count. What happens if I just run that? Let's try that here. I think it's going to be ugly. Okay. And so the reason so this is close, but it's kind of telling us there's an iterator on this thing coalescing by. I think if we do, we can think, if we take this, we can do collect. Now it's probably going to need to tell us how to collect it. So let's see if we can vec. Can I just do that? Can I get away with that? Maybe. Sweet. Yeah. So, okay. So now I've collected it into vectors, and you can see here. So now I get exactly what I'm looking for. So recipe 1, 4 sprinkles. Then I get 3 sprinkles and a butterscotch, blah, blah, blah. You'll notice the order changed every time. Last time I had 4 chocolates first, but I still get 4 chocolates down here at the end. So now I've got this way of generating all possible recipes. So that's exactly what I want. So what I'm really going to do here is let's go ahead and say, we'll do something up here. We're going to say let mute best score equals 0. And we're going to return best score. Okay, this is going to be a familiar thing. I would love to I tried to figure out how to do this all through with just chaining things, and I couldn't make it work. So we're going to have to do some nested for loops. It is what it is. So we'll come over here and we'll say let score equals 0. And that's going to have to be mutable. And now, come back here, instead of printing this, and instead of collecting it into a vector, we're going to say for, let's just start with x in. We'll get rid of, dedupe with count, we'll get rid of this. And so you can see right away that the linter is telling me that's going to return a U size and a string. So in fact, let's not make it that. Let's make it, let's see, we'll call it like num and ingredient, because that's what the string is the ingredient. So now we have a number and a string in there. Let's do a for loop. And so for each of these, so what we're going to do is we're going to say for the combination, we're going to loop over all the ingredients in it. And we're going to say, we're going to need to like add this into our running score, right? Now it's interesting, the way we calculate a score, what we really need to do is sum together the properties across all the ingredients. And so I think we're actually not going to call this score. Let's call this recipe. And this is going to be equal to quality, not qualities, what do we call it? Properties. Properties, and then we're just going to do, oh, it didn't autofill for me. That's annoying. Let's grab this. Actually, let's do that. Let's make a, do we have any function, anything on properties? Not yet. Okay, so let's come up here and we'll do simple properties function new properties. And so if we need a new properties, we can do it just like this. And we'll say properties. Oh, now you fill for me. 0, 0, 0, 0, and 0. I wonder if I can cargo format this. Yeah. Okay. So I don't have to do all the printing. Okay. So I've got now this. So now I can come down here and say my recipe is going to be a, where did I do this? Let mut recipe equals properties new. So now I get a new recipe, and the recipe currently has none of these characteristics. It's all zeros, right? But now I can come through here and I'm going to say for each of these, I'm going to get back an ingredient name and a size. And so what if I can do recipe.add, and I can now say I and none. So I'm going to add in 5 cinnamons or whatever it is, right? So now I need an add function up here for properties. So let's come down here and we'll do function add, and it takes self. It's going to take, I believe the next thing was the ingredient name. It is, maybe it should just be an ingredient. Yeah, it should just be an ingredient. Let's come down here. We can say self.ingredients dot get I, like that. And so we need to now come up here, add self. Let's see. So we want this to be a new ingredient. So ing, and we'll call this not ingredient properties. And we need a number. So we'll call it num I64. And that is going to return nothing. So it should be okay like that. And I think we're good here. Let's see, properties. Arguments are not correct. We have an expected of properties, but we got an option properties. So let's do, we need to take this and do dot unwrap. And let me do it again. Argument of type I64 is missing. Isn't num and I64? Num's a U size. So let's see if we can change this as I64. Can I do that? Properties, expected struct properties found in a enum. We should really just try to fix that. Okay, so we can point at, that's good. It's expecting that, and we need that. Now it doesn't like I, so it says, you can see here it says consider borrowing here. Again, I don't know. We just trust the linter to tell us. It's not satisfied. Required bound introduction by this cell. What can I do here? I wonder if I can string it. Now we're back to something else. Cannot move out of this. So, I wonder if I can clone it here. I get to the air. Does not have the copy trait. Can we give it the copy trait or the clone trait? Let's see. So we come down here, derive that. So what if we now go? Oh, not here. We need this one. Clone. Does that make you happy? Still not yet. I'm gonna run this in C because I'm having a hard time following it in the pop-ups. See, properties cannot be dereferenced. Okay, what if I get rid of you? Ooh, that looks promising. Run. Okay, so I still got my 0, but I never changed best score. So we're running. We're not crashing. That's a good sign. Okay, so we're now going through and we're adding into our thing for each thing, we're adding in the ingredients necessary. Now, we don't have an add function yet, do we? We've always started it, but we haven't actually made it. So what we're going to do is we're going to say, we need to say self.capacity plus equals ing.capacity, self.durability plus equals ing.durability, self.flavor plus equals ing.flavor, self.texture plus equals ing.texture, and self.calories plus equals ing.calories. And that is our add function, which it does not like. What do we get? Consider changing to mutable. Oh, let's make this mutable. Mutable self. Beautiful. Aha. Okay, so we need that. We need that times num, because we do intend to use num here. So let's paste that in here, 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 and here. So now we've changed. So now when we were keeping our recipe, which is also a properties object, and we're going to just keep adding in the different types we get for this in this loop where we are dealing with one recipe at a time, where a recipe was like, let me come back up, like this is one recipe where we have 1 sprinkles, 2 butterscotches, and a chocolate. And so for each recipe, we're going to add all the ingredients together. Now we need to do let score equals recipe dot score. We'll have to write that. And we can say if score is greater than best score equals score. Save that. So now all we need to do is write this function that'll show us what the score is. So let's come down here, fn score self returns an I64. And what is that going to look like? So we need the ability to just multiply together, I think, the different things, right? So we just need, I guess we'll just do, and we need to make sure that if they're less than 0, so we need to do, let's do this. We'll go up here and we'll do use standard compare max. So we can get our max function here. And now we can say max self.capacity, 0 times max self.durability, 0. I think I can do this times max self.flavor, 0 times max self.texture, 0. I guess that's it. That's the score. We're returning those. We're multiplying those 4 things together. So now, we might be done. We need to fix this because right now we're doing 4 tablespoons and we want to do 100 tablespoons, which is going to generate way more options here. So we're going to make sure we run this in the release mode because it's a lot of brute force. But I don't think it'll like overwhelming, and we get an answer. And we get our answer 213-67368. 213-67368. Beautiful. Part 2. Someone asks if you make another recipe that has exactly 500 calories and it still has 100 teaspoons, same ingredients, same scoring. So this is actually super trivial to change. What we're going to do is we're going to come here and we're going to say it's not going to return an I64, but it's going to return 2 I64. And it's not going to return, we're going to say let mut best score equals that. We're going to say let mut best 500 cal score equals 0. And then down here, we're going to return best score, best 500 cal score. And that is basically it, except for now we just got to do if, let's see, recipe.calories equals 500 and score greater than best 500 calorie score, then we're going to say best 500 calorie score equals score. I think we're done. So all we're doing here is adding another check, and along the way we can just check the if the calories are 500 and it's better than the best, then we count it. So we run this, and oops, well, we get our result. Let's make it. I have to make it pretty before we go check to see if it's right. So we can come down here and say let p1 p2 equals pantry.best score, and then we just put very nicely this as p1. Get rid of debug print p2, and there we go. We run this, and oh, what do we do wrong? We need a semicolon. And we get answers. So now we can go check if it's right. 1766400. 1766400. So 2 more gold stars. I'm gonna call it here. Hopefully this was interesting. Definitely took me a minute to wrap my head around how I was gonna organize this, and the whole combination with replacements plus dedupes with count worked out really nicely. One thing I will highlight, just if you do use dedupes with count, anytime you're deduping with count, deduping, etc., that only dedupes things that are in order the same. So if you have like A, B, A, it does not dedupe them. If you had A, B, it would not dedupe them. If you had A, B, it would dedupe them. So you just have to be aware of that when you're using dedupe. But luckily here, combination with replacements is returning them sorted. So we're okay. All right. Thank you so much for sticking around till the end. I really appreciate the support, and I'll talk to you next time. Bye.